Hello everyone and welcome back to Kanai's AI Lab. As we all know, AI is becoming a game changer in healthcare. From early disease detection to testing, faster diagnosis. It's basically helping us to make smart. So we will be exploring one such case in this particular video where AI looks at chest x-rays to detect the sign of pneumonia, which is nothing but a condition that affects millions of people globally and become a life-threatening effect if not identified early. So as I mentioned in this video, I will be showing how we took a trained AI model and turned into a simple working app, something that can be accessed and used from anywhere. Also, please note, I will not be touching upon how I trained the AI model. That will be shown in the next video, which in detail. First, let us try out a quick demo to see the model, how it predicts. So I'm opening to one of my browser where my HTML page is ready. You can see this is my interface, HTML web app interface. I can upload the images here. Let me load one of the images. My images are available in one of the folder, which is nothing but calling part B deployment. There is a subfolder called static. So this particular folder has lot of images correspond to chest X-ray. Either it can be normal X-ray or it can be a pneumonia based X-ray. So machine doesn't know anything. I'm just passing an image or uploading an image to the browser. You can see I'm just submitting. Yep, we got image as well as the prediction. Beautiful, isn't it? This is pneumonia detected page. Something giving an advice, consult your doctor immediately. So with that, I'm going to take you to different steps of preparing it a deep learning model or deploying a particular AI model in the Flask API. So I want to take you through the structure of the project first. Let me navigate to my folder. So this is my folder. As you can see here, there are a lot of subfolders are available. I have something called static first. You can see the static. This is gives the different types of inference images. As you can see here, when I open this, I can see a lot of images inside. So this is the images. It consists of normal X-rays and pneumonia X-rays. We will not be giving any information to machine which belongs to which category. So that's what our role it is. So now we have another subfolder which is actually the base thing of our activity, which is nothing but we have a particular pneumonia detection Python file. Where it is? This is nothing but pneumonia Python detection, which is in IPYNV format. You can see here. So here in this particular case, as I mentioned, we will not be detailing how it is prepared. So I can give you some hint. This notebook is a VGG based transfer learning approach to train a deep learning model for detecting pneumonia from chest x-rays. You will also notice that there is another file called VGG 16 model.h5, which is nothing but a saved model which is trained in the pneumonia detection IPVNP file and saved in the H5 template. So as I mentioned, I am not going to touch in detail, but for your understanding, I can take you through the notebook to mentioning which is a major and important step. So I am going to connect with my Jupyter notebook. Give me a second time. So my notebook is in my browser only. Let us go to Chrome. So here is my home tab. So let us close all the drawings. It's disturbing us seriously. I'm just connecting to my Jupyter Notebook homepage. As I mentioned, this is the page we were discussing about. The same folder, but this is in the notebook. As I mentioned, we have static page. We have something called pneumonia detection and the saved model in H5 format, the same file. So if you want to see the pneumonia detection, how I train, you can see the major important steps in this particular. And let it load first. You can see uh, the model hierarchy and the images and some exploring the data, different types of images. And this is the model structure. This is the summary of the model, which is basically a kind of a CNN model which is on top, transferred into VGG16, and we have compiled it. This is the training epoch. You can see that I have taken 5 epoch. The training accuracy is almost 0.95 and validation accuracy approximately 0.77, which is fair enough for the prediction. These are the performance characteristics based upon the model loss and based upon the model accuracy. And finally, we will be validating some images. And this is what I wanted to show. We have saved the model as H5 template, which is available in our folder for direct access. Now, I'm taking back, which is something called another Python file. You can see app.py. So this is nothing but a Python file named as app, which is a Python extension, py extension, which is the core backend file that makes the model usable in a web application. So from where the Flask framework come in then? So let me open this particular, you will understand. So this is the Python script for complete front backend activity of app.py. So you can see we are importing the Flask framework. So this Flask API acts as a bridge between the user and our model. It handles file to upload. It runs the prediction application and send the result back to the user front end. As you see, we are started with importing all the libraries. After that, we imported or we initialized the application name, which is something called app only, and loaded the images and given the dictionary. How do we going to predict? You can see here, we are going to take a 0 for normal X-ray and we are going to take 1 for X-ray. So the predict label function, in this particular case, which is nothing but giving the prediction load, it converts the model into prediction. Apart from that, there are 3 routers. You can see here, there are 3 routers, which is basically routing this particular app to the front end. Routers we have a page router and we have an import page router. Once the prediction is made, it returns to the front end HTML page along uploaded image field. This is all about python.appy, and we have one more file. As I shown, we have one more file that is very important. You can see within the template folder, this is called index.html. I named as index.html. I'm going to display this in a notebook only. So what is this basically? This is nothing but an HTML front page. So I need to scroll to right. 1 second. Yep, it is on the top. Yeah, here it is. This HTML, which is the front facing web page for our app. This is where users can upload their chest X-ray and view the prediction result. It's simple and responsive bootstrap based connecting Flask to handle user input and display the output returned by the model. So this is all styling part. We have a title here and where we do a templating font, etc., and connecting how it is. So with that understanding, we will be moving how we can run a prediction but by using this complete setup. So for that, I'm going to do complete some prerequisite steps. So you can follow along with me. So what I'm going to do, I'm going to open Anaconda prompt from my system. Anaconda prompt. Here it is, Anaconda prompt. So it's opening now. Yeah, it's open, but the directory somewhere base only. My directory where the folder is in different folder. So what I'm going to do, I'm just taking my folder where all my setup is available. I'm copying the address and pasting into the directory change option. So you can see here, I am going to, I think the copying is not happened properly. So I need to copy the path. 1 second. Yep. This is copying the address now. Now I'm going to paste here. CD change of directory, then the path. Yeah, the path is directly changed. Now, so we are going to install Flask by using the pip install function. Pip install Flask. As you can see, something gone wrong. Okay, spelling error, doesn't matter. Pip install Flask. It's installing now. As you can see here, it's already available in my system. Since I installed long back, it is available. If you are doing for first time, you have to install the pip install. You have to install the Flask by using the pip install operation. So after that, we know there is a backend function which is app is in py format, which is basically a Python file. I am going to take that particular file, Python app.py. So this I'm going to execute. This execution will take another 20 seconds. So I am waiting the connection to the localhost server. So once the server is connected, I'm going to get the localhost link. So it's connecting now. So after the connection is setup is ready, I will be able to get the localhost link, which is nothing but starting with HTTP. It is available here. I'm copying this localhost link and pasting somewhere on another tab of my browser. Yep, I'm just pasting here. So this localhost link is pasted. Now, yes, we are connected to the HTML index page. The UI will be like that. So I have an option, as I mentioned at the beginning of this session, there is an option to load the image. This time I'm going to load another image. Yep, the process will be remain same, and submitting it. I can see again a pneumonia detected. Consult your doctor immediately. If you want, you can check with one more images. So I'm taking the third one this time. Submitting. Yes, this is another images which is detected pneumonia. How to consult the doctor immediately. So with this, we are going to conclude this video on turning the AI into a Flask API model. So which is nothing but a framework, Flask framework, which is used for deploying purpose. So deploying a deep learning model with Flask is very powerful and very efficient. So by following this structured approach, you can bring AI-driven healthcare solution into real-world applications. So I hope you understand, you enjoyed this video on deploying a model, AI model into a web application. So we will be connected with multiple folders, and finally we deploy to identify pneumonia present in the chest x-ray or not. So again, once again, thank you for joining this video. Stay tuned for more important and relevant content on AI.